Look up at the night sky. What do you see? Maybe you see a scattering of stars, a bright moon, or the faint milky band of our own galaxy. It feels vast and random, a beautiful but chaotic sprinkle of light against an endless black canvas. For centuries, this was our view of the cosmos. But what if I told you that this picture is completely wrong? What if they are part of something unimaginably larger, a hidden structure that connects everything across billions of light years? Imagine a spider's web, glistening with dew on a misty morning. Now imagine that web stretching across the entire observable universe. The shining dewdrops are not water, but entire galaxies, each containing hundreds of billions of stars like our own sun. About 13.8 billion years ago, our entire observable universe was compressed into a point of unimaginable density and heat. It was a searing, hot, perfectly smooth soup of fundamental particles and energy. These tiny temperature variations in the cosmic microwave background are a direct snapshot of the infant universe. During this incredible expansion, tiny quantum fluctuations were stretched to astronomical scales. These microscopic quantum jitters were magnified into the macroscopic density ripples that we now see imprinted on the cosmic microwave background. The slightly denser regions, the cold spots on the CMB map, were the seeds of future structure. This created a fantastic phenomenon, sound waves sloshing through the primordial plasma. These are known as baryon acoustic oscillations. When the universe cooled and became neutral, the show was over. The sound waves stopped in their tracks, frozen in place. The vast majority of a filament's mass is the mysterious dark matter. We know it exists because we can see its gravitational effects on everything around it. About 85% of all the matter in the universe is this mysterious, invisible substance. It got a head start of 380,000 years on normal matter. It began to clump together in the slightly denser regions laid out by the initial quantum fluctuations. They created the gravitational scaffolding, the invisible framework into which the normal matter would later fall. In the expanding universe, this created a cosmic battle. The expansion of space was trying to pull everything apart, while gravity was trying to pull everything together. A tiny initial advantage for gravity snowballs over billions of years, leading to an enormous accumulation of matter. The rich get richer, and the poor get poorer. An elongated, slightly lopsided clump would first collapse along its shortest axis, forming a flattened, pancake-like structure. This pancake would then continue to collapse along its next shortest axis, squeezing the matter into a long, thin tube. The entire intricate architecture of the web emerges naturally from the simple, relentless action of gravity. The normal gas, mostly hydrogen and helium, immediately began to fall into the gravitational wells that the dark matter had been digging for millennia. This process turned the dark matter filaments into a grand cosmic conveyor belt. Once on a filament, the gas would be channeled along it, flowing like water in a riverbed towards the deeper gravitational wells at the filament's ends. Within the filaments themselves, smaller pockets of gas would cool and collapse to form the first stars and the first proto-galaxies. This process, known as cosmic accretion, provides the fuel needed to sustain star formation over billions of years. The vibrant star-forming spiral galaxies we see today are a direct consequence of this ongoing cosmic feast. The breakthrough came from pioneering galaxy surveys. Over several years, astronomers meticulously measured the redshifts of thousands of galaxies. This was our first true glimpse of the cosmic web. It was a revelation. Starting in the year 2000, the SDSS telescope began a systematic campaign to map a quarter of the entire sky. They could gather more data in a single night than the pioneering surveys had collected in a decade. With this flood of new data, the cosmic web snapped into sharp focus. Astronomers realized they could use the most distant objects in the universe as cosmic lighthouses. Every time the quasar's light passes through a filament of hydrogen gas, another dark absorption line is carved into its spectrum. This has allowed us to see the gas filaments directly, revealing them as vast, shimmering structures of diffuse hydrogen. Stretching over 500 million light-years long, it was a staggering discovery. This colossal chain of galaxies and clusters stretches for an astonishing 1.37 billion light-years. Its estimated size is a mind-boggling 10 billion light-years across. The Bootes void, sometimes called the Great Nothing, is a roughly spherical region of space about 330 million light-years in diameter. If our Milky Way were placed at the center of the Bootes void, we would not have known of the existence of other galaxies until the 1960s. Because they are so empty of matter, voids are the places where the effects of dark energy are most dominant. This revealed our true home, the Laniakea supercluster. This colossal structure contains over 100,000 galaxies and stretches for more than 520 million light-years. All the galaxies within it are flowing towards a common point, part of the same gravitational basin. We are currently traveling through space at over 600 kilometers per second, a journey dictated by the gravitational pull of the Laniakea structure. Our galaxy's fate is tied to the fate of our 100,000 neighbors. We are living inside one of its filaments, a part of its intricate and beautiful design. This is not just an abstract astronomical fact, it is our cosmic identity. A new generation of telescopes, both on the ground and in space, is being designed specifically to map the cosmic web in unprecedented detail. What is the true nature of dark matter? And what of dark energy? These future surveys will test our theories to their breaking point, revealing whether our current story is correct. Through science, we have managed to look back to the dawn of time, to map structures billions of light-years away. The cosmic web is far more than just a map of matter. It is a history book, a physics laboratory, and a philosophical guide all rolled into one. We are not random specks of dust in a meaningless void. We are part of a dynamic, evolving, and deeply connected cosmic structure. We are the children of the web. The quest to understand it is a journey to the very horizon of human knowledge. And as with any great exploration, the discovery of one horizon only reveals another, even more distant and mysterious, beckoning us to look deeper, to ask bigger questions, and to continue our endless search for understanding.